established. So if it is a amplitude modulation, frequency modulation, phase modulation, if you take in analog, you take the quadrature amplitude modulation. Okay, so all these things you will get it. Then if you take a digital transmission is nothing but we are going to transfer data 1 and 0. So generally we don't have a digital data, okay, because all the basic signals are in the nature of analog in nature. Whatever the voice and data and video is not in a digital mode, okay. At the same time, any human being or if you take anyone can hear and can understand easily only the analog signals, okay. Voice signal, data signal, the any instrumental signal, everything we can hear and we can enjoy only it's in the analog format. So we can't hear and we don't know the digital signal. If signal is in the 1 and 0, that is not able to understand by us, okay. That can be understood only by the machines only. So all the analog signals converted into digital because the digital technology need only low power, okay. It occupies less space. So all these things, the technology is tremendous changes in the technology, okay. So everything we put in single IC, so that plays VLSI and ultra VLSI, submicron VLSI plays a vital role, okay. So whatever may be the application, bring into a single small chips, okay. So that can be done by the use of the digital era. So now our Modi ji insisting us everything put into a digital India, all these things, okay, digital world, all the transactions, everything, whatever may be, is in the form of the digital, okay. So for that, we need to convert whatever may be the signals is into digital form, okay. So for this, we have a some time is divided into periods of fixed length called the clock cycles, okay. So for digital transmission, okay, the input is in analog, the output is in analog form, but we need to convert analog into digital by the use of A to D converter. Then the transceiver is in a digital modulation and digital demodulation technique. Again, the digital demodulated output, okay, you will convert into analog form, then we can able to hear it or view it, okay. So this is analog and the digital transmission systems. So the methods is also given here: amplitude shift keying, frequency shift keying, and phase shift keying. So amplitude phase shift keying is the carrier, okay. Here the carrier is in the high frequency signal, your input is in digital 101 like that. So the carrier is, okay, depending upon the data, the amplitude of the signal changes is called amplitude shift keying. Keying is nothing but your input is in form of 1 and 0, not the carrier, okay. Similarly, the frequency shift keying is nothing but input is 1 and 0. So the carrier is analog in nature. It's a high frequency signal. So if 1 is different frequency, if 0 is different frequency, that is frequency shift keying. Similarly, for phase shift keying is, if the data is 1, there is a 0-degree phase shift. If input is 0, there is 180-degree phase shift. So the carrier phase of the carrier signal is changes depending upon the input data 1 and 0. So this is nothing but digital modulation, okay. So in analog, The input is in analog, it's a continuous signal. But in digital, the input is in discrete in time, 1 and 0. But both the cases, the carrier is in a high frequency signal, analog in nature. Okay, so but if you want to make it as a the carrier is also is in the form of digital, full digital, then we need a so many, that code division, multiple access, space division, multiple access, spread spectrum, all these things came into picture. So amplitude modulation, how this is analog signal, carrier signal, modulated signal is given. Then frequency modulation also you have it. Then phase modulation, the signal also you have it. So you look at it, the phase of the signal is changes. Then amplitude shift keying, I told you this is the digital data, carrier is in continuous, how the signal is going to be changed. So this is frequency shift keying. If one is one frequency, if the data is 0, different frequency, another frequency. Then phase shift keying. Okay, so depending upon our input data, phase of the carrier is changes. Either it may be a 0-degree phase shift or 180-degree phase shift. So in digital, this is a binary data sequence is in the form of the input data is in the form of, okay, NRZ, RZ. Okay, so depending upon this, there are many ways we can give the input signal for obtaining good received signal. Okay. Okay, if the input is non-polar, return 0, non-return 0, return 0, non-polar, return 0. So many ways, if depending upon the input, the output